Hey, welcome back. By this point, you've done some work with series and parallel circuits, and we've got a good grip on it. But now I'm going to actually put those rules down in a write-downable form so you can see them and use them. Simple series circuit. Let's just talk about this circuit having two resistors in it. We'll get more complicated later. We'll call them R1 and R2, and we'll call it V battery. All right. What you noticed is we have this idea of a total resistance of the system. We call that the equivalent resistor, or REQ. And what you noticed, I'm betting, as you added resistors in series, it increased. Why? Well, simple reason. We can go back to our definition of resistance, rho L over A, and as we add resistors, we're effectively making L larger. Basic idea here. Now, a couple of rules. One, whatever voltage you gain from the battery, by the time you get back, you have to have lost it all. We lose it here, and then we lose some more here, and any other resistors we have, until we've lost it all. Basically, if I gain 9 volts here, I have to lose a total of 9 by the time I get back. 3 and 6. 2 and 7. It depends on what kind of battery you're looking at and what kind of resistors you're using. Rule 2, the current is constant. No matter how many resistors you have, because they're in series, they keep going from each other. Now, if we remember Ohm's law, well, then I can say I total times R equivalent equals I1 R1 plus I2 R2. You can see that's coming from V plus V plus V. But all these I's are the same. So we have this total resistance is the sum of all the resistors. That's an important idea. Okay. Let's do an example where we actually use this. These two are just as important as this. This and this are really important as well as this being important. Simple example problem. We have an 18-volt battery in series with a 3 ohm and a 6 ohm resistor. I want to know what's the equivalent resistor? What's the current to the 3 ohm resistor? The voltage across each of the resistors and the power of the 3 ohm resistor. We can do this pretty easily. And in some cases, I may just ask you to say, what's this? And you have to figure out that, oh, I have to do these things first. So let's look into what's going on here. The equivalent resistor, that's pretty easy. It's the sum of all the individuals. So it's 3 ohms plus 6 ohms, it's 9 ohms. Okay. What's the current through the 3 ohm resistor? This guy. Well, that's a tough problem. I can't say it's 18 volts divided by 3 ohms because the 18 volts isn't what I lose here. The 18 volts is what I lose over the equivalent resistor. Effectively, I can say I have a circuit. It looks like that. Like that. So what I can do is I can say, oh, well, what's the current to the 9 ohm resistor? I can, oh, V equals IR. 18 equals I in a 9 times 9. Amps. But that's not the question. The question is the 3 ohm resistor. But keep in mind, because they're in series, the 3 ohm resistor, the 6 ohm resistor, and the 9 ohm resistor all have the same currents. So we found the current in the 3 ohm resistor. Cool. What's the current in the 6 ohm resistor? Yeah, it's also 2 ohms, 2 amps, because they're also in series. Last question. Well, second to last question. What is the voltage across each of these individually? Well, it's pretty easy to do. V equals IR. Okay. V equals 2 amps times 3, or 6 volts. V equals 2 amps times 6 ohms, or 12 volts. Hey, look at that. 6 volts, 12 volts. I gain 18, I lose 18. Nice. Lastly, what's the power in the 3 ohm resistor? Well, power is IV. I know the current, it's 2 amps. I know the voltage, it's 6 volts. Or 12 watts. Great. All right, I'm going to put one together, and I want you guys to try this on your own. All right, here's your question for the series problems. You have a series circuit, 3 resistors. There is a 2-volt drop across the 3 ohm resistor. What is the voltage of the battery? Give it a shot.